Uze, over to you.
All right. Excuse me. Thank you, Urim, and thank you all for joining today's session. As Urim mentioned, my name is Wu. I'm part of the data science team at VMware Tanzu Labs, and I have the wonderful pleasure of working with a brilliant team of data scientists, and we get to collaborate with clients from a wide range of different industries on valuable business problems, and we collaborate with our customers to build out smart apps to support their business objectives. And so, as you can see from the title today, I'm thrilled to have this opportunity to present and share with you some stories on how to unlock extraordinary value with data-driven smart apps. And I hope that you find the contents in today's session both interesting and helpful. Right? Now, before we get started, we do have to just flash out a couple of standard disclaimers for your information. So I'll give you a moment to read through them. Just a few seconds here. And okay, here we go. Let's get started. All right, so now the title of today's session is how to unlock value with data-driven smart apps, right? And so I think one good place to start is to define what a smart app is, right? Because it might mean different things to different people, right? And many of you have probably seen diagrams like the one that you see here, which defines a successful product as those that are at once desirable for users, feasible to build, and viable for the business, right? And I often get asked like where data fits in this context, right? And kind of the way I see it, I think the need to extract value from data, the need for machine learning and AI, really simply is just one component of this feasibility side of the diagram, right? For example, let's think about I don't know, Amazon, right? They specifically, let's say, the recommendation engines for products sold online, right? It's desirable because it helps users find products that they need more easily, right? It's viable because it attracts more business for Amazon, right? And it's also feasible because of two reasons. It's something that can be developed as code, right? This product recommendation engine. And at the same time, data is available on past purchases to build an engine to match customer preferences to the products that Amazon sells online, right? And so in some ways, it's kind of like how Amazon's recommendation engine, it's like smart apps are simply products, successful products that happen, right? Just happen to require data to be desirable for users, right? This is kind of what I like to define as a smart app, right? And kind of to be a bit facetious, like a successful product which does not happen to require data to be desirable for users, I really do see that as an endangered species, right? We see these products rapidly becoming endangered, maybe even extinct, right? And as a data scientist, this might be my bias speaking, but just let me support that position with a couple of statistics and some numbers, right? This is a statistic from a recent article of the Harvard Business Review, right? And they estimated that AI will add 13 trillion to the global economy over the next decade. That number, 13 trillion, is actually more than the gross annual GDP of China, right? So it's a pretty big number. And based on this statistic, like user demand for, at least the belief in the value that data and AI is providing, we can at least infer that this is growing, right? Now there's a flip side here though, there's a catch. Many organizations and their efforts with AI and ML are falling short, right? In a survey that the Harvard Business Review ran on thousands of executives about how their companies use and organize for AI, only 8% of these organizations were engaging in core practices, right? That were supporting the widespread adoption of data analytics and AI in their organizations, right? They found that actually most of these companies, so those in this, 92%, right, were only running like ad hoc proof of concepts or viewing like plug and play or viewing AI as like a plug and play kind of off the shelf tech that provide full automation, right? Which obviously isn't the case for machine learning and artificial intelligence, right? And so if the reason why organizations have been facing challenges to adopt machine learning, to adopt the use of data and building smart apps is the lack of these foundations, a reasonable question to ask, right, is, well, what are these foundations, right? Tell me more about what these foundations are so we can not be part of the 92%, but be part of the 8%, right? And I guess, in my view, it really comes down to three main foundations, right? So it's the experience, the methodology, and the technology, right? Kind of coming up with the right set across all of these three foundations for organizations to be able to meaningfully adopt data science to build smart apps, right? And what we're going to be doing in this session today is actually we'll be touching on each of these three foundations. But I guess as a way for us to get started, I'll kind of touch on and provide a brief description of all three of them to provide some context and kind of get you up to speed in terms of what we're going to be talking about and discussing in the webinar today, right? And so let's start with experience, right? Having the right experience and expertise is important in smart app development because it's not just data scientists who are going to be doing this work, right? Right, there's a machine learning model that is perhaps embedded in the user experience, but to build a smart app successfully, we actually need to get help from a balanced cross-functional team of team members who are like skilled in product management, design, software engineering, along with data science, right? Along with kind of the right mix of skill sets to be able to deliver a smart app successfully. It also helps to have a seasoned understanding, right, of what works well based on past experiences in developing and building smart apps, right? So that's one. So having the right experience to be able to create smart apps and do that successfully. Number two, methodology, right? So, experience is great, but having the team adopt processes and approaches that facilitate continuous feedback from users, and also kind of ensures a focus and iterative development of the model that sort of aligns against the business goals and the product goals that we've been set out to mark against. I think that's another key foundation that's required for product teams to be able to develop smart apps successfully, right? So two on methodology. The third pillar here is tech, right? We never want tech to be the bottleneck to slow down the velocity of developing smart apps, right? Putting together the right set of tools to increase productivity is key, right? And in this session, there's a lot of different tools for PMs, for engineers, for designers. I'm going to focus specifically on the tools that are required and needed by data scientists to be most productive in the context of building a smart app. Yeah. So let's start by sharing with you some more stories, some more examples of why experience, in our view, is a key accelerator in building smart apps and why we see that as a key foundation. Experience. Oh, my apologies. Experience. So, we've actually had the pleasure of collaborating with clients in building smart apps over the past decade. So we got started as an organization in terms of data science practice within VMware Tanzu Labs in 2010. And I guess since that time, we've sort of learned a lot about what industries and verticals are facing in terms of business challenges that can be best addressed by building a smart app, right? And when I meet with client data scientists who are kind of beginning to explore building of smart apps in their organizations, they often ask like kind of where to get started, right? And which opportunities are sort of lower hanging fruit in each of their respective industries, right? And kind of what I've laid out here is sort of a selection of engagements by industry that we've delivered in partnership with our customers over the past decade, right? Now, do keep in mind that this list isn't at all exhaustive, right? But I'm hoping that at least one or two of the items that you see here are relevant for the respective industries that you're in and resonate with your current business needs, right? Of the ones that you see here on this list, we'll touch on a couple of the smart apps and kind of walk you through a couple of them in today's presentation. Let's start with this one. This is actually a smart app that we built for a retailer. And they were actually, the customers of this retailer were expressing some dissatisfaction with the existing quality of search that they were getting with the e-commerce app, right? And, you know, they kind of expressed some frustration in terms of, oh, you know, I'm not getting the results that I'm looking for when I type in keywords, let's say, to the search box, right? And we worked with the customer to not only improve the quality of the search results that customers get back, let's say, from the mobile app. And we did that by developing data science models using natural language processing and a bunch of other methods to improve that experience. But we also collaborated with the PMs, the designers, and the engineers on the team to embed these analytics and context in a meaningful way for the end users, right? You know, I'll give you a couple of examples of kind of the improvements that we found, you know, as we're developing this product in collaboration with the clients. Before we got engaged in making improvements to the smart app, let's say if a user typed in the search word pasta into the search box, it showed all products containing the word pasta, right? This included not only noodles, like pasta noodles, but also sauces, pasta accessories, you know, you name it, anything that actually has the keyword pasta in its title, it was returning as results, right? But in context, like when people search for pasta, let's say in a grocery app, they're not looking for, you know, necessarily, you know, accessories to make pasta. In most cases, they are looking for noodles, like the pasta noodles. And so the data science model that we built kind of under the hood, it learned patterns of what items were actually purchased by users when they searched for the keyword pasta. And so rather than, you know, have like, you know, pots and pans that you use to cook pasta, maybe even pasta sauces show up at the top of the list when you search for the keyword pasta, you know, we return things like ravioli, like spaghetti, like tortellini, pasta noodles that the customer was actually looking for, the most likely items that they're looking to purchase when they search for this keyword, right? And by kind of going through this process, you know, this pasta thing was one example. It allowed the app to show more relevant search results to users, which ultimately improved their experience with the product, right? As you can see here in the unlocked value section, within 3 months of this product relaunching, with the improvements that we made to the app, the company saw a 5% increase in ads to basket, right? And we believe, based on this A/B test, that this was a direct result of incorporating these additional smart features into the app. So that's an example of a smart app that we built in collaboration with the retailer. We'll move on to something a little bit different. This is something that we built for a global logistics company, right? And you know, when you think about logistics companies, you know, most of the time, at least for most of, you know, kind of my lifetime, like when I was sending a parcel to a destination, like the destination that I had in mind had an address, it had a phone number, and it also had a postal code, right? But what I learned, that I was like learning more about this opportunity and engaging with the customer, was that there are geolocations, geographies in the world that actually don't have postal codes. And so from the perspective of a courier service, you know, if you're trying to find, you know, an address and it doesn't have a postal code, that can lead to a very costly mode of operation, right? Oftentimes it's like, oh yeah, go to this landmark building, and I'm kind of 2 buildings away from that landmark building, you know, something of that sort, in terms of descriptions that they use or the logic that they use to deliver the parcel, right? You know, we felt like there was sort of a better way to do this, because what ended up happening was that the person who was delivering the parcel needed to make a lot of phone calls to like contact the receiver and like figure out where this person was living, because of the fact that there aren't postal codes, you know, in that scenario. And then just, it was very costly to get that done. the cost of the phone conversations, and also just the length of time that it took to get the parcel delivered was increased because of this extra effort, right? To manually figure out where these addresses are without postal codes, right? So what we did was we actually looked at historical delivery patterns in scenarios and in deliveries that did not have postal codes. And based on, let's say, parts of the address that were provided, or the time of day, or the type of parcel, or the sender, right? Using other contextual pieces of information, we're actually able to pinpoint the geolocation that is the most likely location that parcel should be addressed to and delivered to, even if we didn't have the actual postal code at hand to be able to make that call, right? And so by incorporating kind of these smart features into the apps that the couriers were using to deliver the parcels, we improved the quality of service, right? Because the customers got their packages faster, and it was also reducing the cost of operations by reducing the number of phone calls that the delivery folks need to make to the receivers, right? And this was a huge success. And we didn't know when we started this project that it would leave such a huge impact, but based on a business case that we built with the customer after deploying this improved smart app, we estimated a 2.3 million in annual savings through better route efficiency, reduced call center activity, and increased customer satisfaction, right? So another example of a smart app in a slightly different context now for a global logistics company, and how we made use of data and ML and AI to improve that customer experience, right? And unlock additional value for users. I'll share with you one more example, right? The smart app examples that I shared with you so far, they're kind of had the general end users in mind, right? So in the case of the retailer, the grocery company, the folks who were making deliveries and getting groceries delivered to their homes, or maybe fulfilling an order online for some grocery shopping that they're doing. The logistics company, end customers, receivers of the parcel getting their packages in a shorter amount of time, right? And leading to increased customer satisfaction on the end user side of things. Now, do keep in mind that smart apps are not only built for general end users, as we've seen in the previous two examples, but also for like enterprise users, right? And in the context of enterprise smart apps, it's really about providing data-driven decision support so that they can increase the productivity of the staff by providing information and context at just the right time, right? And so this is kind of an example of an enterprise smart app that we built for a global bank, right? Now, in this scenario, we partnered with the consumer banking division of a retail bank, actually, to explore ways in which we could perhaps address business challenges around preventing credit card fraud, right? And to provide you with a little bit of additional context, to simplify things a little bit, I mean, there are kind of, broadly speaking, two types of credit card fraud, right? First-party fraud is pretty straightforward. Third-party fraud is pretty straightforward, right? This is where, like, I don't know, I would steal Urim's credit card and then like I buy some cool things with it, and then I hope I don't get caught, right? That's pretty, clear cut, pretty straightforward. This particular bank had a pretty good process already in place to be able to detect that type of very simple third-party credit card fraud, right? The one that they were having some trouble with was actually around what's known as first-party fraud. And let me tell you a little bit about what first-party fraud is. So this is one where like maybe the fraudster would take the national ID number of person A. They would take the home address of person B. They would take the phone number of person C. And they would kind of mix and match and kind of create this Frankenstein's monster of a synthetic identity, right? And note that, people, person A, B, and C, one or all three of these people may have been already deceased, right? And kind of with this synthetic identity, the fraudster would then apply for a credit card. In most cases, they're not going to get approved, right? The existing rules-based logic that banks have in place to protect against this will at least provide a first line of defense, right? But in some cases, things fall through the cracks and they get approved for the credit card using this synthetic identity. And once they're kind of in, the fraudster now begins plans to profit from this scenario, right? What happens is that they don't just kind of immediately start making purchases and cash advances. They take a much more nefarious approach. Some of these fraudsters are much more sophisticated, like they kind of behave like good customers early on by making some small purchases, balancing out their bills. But after some time, after they've established credit, established some trust with the bank, they're going to apply for a credit line increase. In some cases, they're going to get approved, right? So now their line of credit is bigger. The potential cost for the bank and the risk for the bank is bigger. At that point in time, the fraudster makes a huge cash advance and then they disappear, right? And this type of synthetic fraud, first-party fraud, this is costing the banking industry $17 billion per year, right? And a recent statistic has shown that this represents about 10 to 15% of a bank's unsecured bad debt. So this is a pretty big and a pretty serious issue, right? So our data scientists and our product teams got together with the client to kind of figure out a way to make this scenario a little bit better for them, to provide with them secondary, tertiary lines of defense against this type of first-party fraud, right? What we did was we built a smart app for fraud detection that very specifically focused on first-party fraud, right? And we kind of began by looking at behaviors of known first-party fraudsters that the bank had information on, kind of what we call labeled data. We compared their historical transactions with those of regular good customers, right? And we made some comparisons, right? And in kind of data science speak, this is kind of known as classification, right? So by training models on these transactions data that we have on good customers versus data for first-party fraudsters, we're able to build a model, right? An ML, an AI that was able to distinguish based on inputted transaction information, which of these customers were, again, normal good paying customers, and which of them were high at risk of being first-party fraudsters, right? Now, this isn't an easy problem. The specificity and the level of detail that we need to be able to precisely distinguish between these two categories requires a lot of data. And so in this particular case, we leveraged over 10 billion records of data, transactions data, that not only looked at kind of purchases and standard transaction data of fraudsters and non-fraudsters. We also kind of looked at how customers were interacting with the bank. We actually found that first-party fraudsters, when they had the option to reach out to the bank using, let's say, a phone call, an online chat, or a chatbot, much more likely to use the phone call option, right? As one example of some additional information that we use to be able to distinguish between fraudsters versus non-fraudsters, right? And kind of through this process, by embedding kind of this AI engine in the context of a broader smart app, we're able to actually increase the accuracy of the existing capabilities by 9-fold, right, which was a huge win. And here again, based on a business case that the customer was able to simulate with us, this resulted in an annual savings of 4 million just on this one credit card product by deploying this improved smart app for fraud detection as an enterprise solution and decision support engine. So, I kind of walked you through 3 examples. Obviously, in the interest of time, I'd love to share with you more stories, but hopefully this kind of gave you an example of how smart apps are developed and the value that they're able to unlock for organizations, not only when users are end customers, but also when users are internal enterprise to the company. We're going to move on now then to the second foundation, which is the methodology piece, right? And yes, it's great to have a skillful team with the right experience to be able to build a smart app, kind of the first foundation on experience. But adopting a methodology, right, that defines and iterates on outcomes that are delivering against business goals, while at the same time facilitating continuous feedback and communication within the team and between the team and the end users. This is equally important for successful development of smart apps. And we'd like to spend a couple of minutes in this presentation to kind of give you a brief overview of the methodology that we feel is required to successfully build smart applications. And I'm going to kind of go back to this definition of a smart app, right? It's a successful product. That's really all they are. That happens to require the use of data and analytics to be meaningful and valuable for users, right? And kind of let's take a step back here. I mean, yes, me being a data scientist, sometimes being very technical, getting into the weeds of developing ML models, we often lose sight of the fact that, like, yeah, these things that we're building, completely useless if users don't use them, right? A product is useless without users, right? And so the need to be able to actually get continuous feedback and align kind of all the technical stuff that not only the data scientists are doing, but maybe also the software engineers are doing, and kind of making sure that's playing back, right, to the end users, and that we're sort of on the right track, getting feedback from them, doing some course correction when needed, so that we're making sure that we're delivering on their needs and at the same time delivering on the business goals, right? And I guess regardless of like how fancy and how sophisticated this cool ML model that data scientists are thinking about developing for the customer and the users are, again, like completely useless if we don't integrate this engine and embed it into existing business processes, existing user experiences that would meet their needs, right? And I guess the idea here is to embed kind of the very technical inputs and outputs of this machine learning model into an existing or new workflow, right? And by doing so, we're kind of creating this new user experience that will effectively allow the users to consume the app, right, most easily, and also derive value from it, right? We don't want to be handing over like Python code and R code and SQL to the users, right? It doesn't make any sense. We need to be able to embed these very nice models that are super valuable, but require the right level of user experience knowledge to be able to weave in and sew in to the right level that users are able to consume it at. And I guess to do this successfully, it's like critically important, right, to do user research, like figure out who's actually going to be using this thing that you're building in Python and R and SQL, right? And get feedback from end users throughout the entire data science development process, right? And this is precisely why in the Tanzu Labs consulting engagements with clients, we request end user participation, right? And at the same time, we also facilitate a reoccurring frequent cadence of user feedback sessions, right? Ultimately, when we're building kind of these smart apps, which in and of itself is a very complex endeavor, right? We absolutely need feedback from the people that are going to be using this thing to make sure that we're on the right track and let us know when we're off track, right? So that we can make sure that we're working on the right things always at the right time. And I guess if we all agree now that like getting feedback from users in the context of building smart apps is super important, what are kind of the processes and the approaches that we can adopt to make sure that this is happening throughout the entire development process, right? Well, one thing is that the product teams that are building out these smart apps, they need to be small, connected, and multidisciplinary, right? They need to be focused, right, on delivering customer value through iterative releases. And this team, like we talked about earlier, right, in terms of the experience that you need, it's not just data scientists working in isolation. Depending on the opportunity, depending on the app, depending on the users, we very much sure we'll need help from PMs, engineers, and designers to make that possible, right? And the second point I want to make in terms of the approach and the methodology, the teams that are doing this work need to be organized around goals that are established by stakeholders, and they need to be empowered, right, to define and iterate on these outcomes that deliver against those goals, right? Because simply put, this team needs to be self-organizing, right, so that they can adapt with agility, so that based on feedback that they're getting throughout the iterative discovery process, we are able to adapt very nimbly and be working on the right things at the right time, so that we know for sure that user needs are being met and that we're not wasting time on things that users will not use. Right? And how do we make that happen? Well, another key point here is not just external communication between the product team and the users, right? But it's actually the team members within the Smart App development team that need to be able to continuously communicate with each other and collaborate, right? And so, we adopt, ways of working. I'll touch on something called pair programming in just a bit, but team communication needs to be informal. We want to be able to favor spontaneous conversation over kind of lengthy meetings, right? We want to kind of put in place opportunities for conversations to happen so that the entire team is in sync and is communicating with each other so that we're aware of the risks and that we know what's working well, right? And so we can iterate upon that and reflect back on it to make sure that we're on the right track. So if this is now about the process and the approach, what about the teaming? I did talk about that a little bit when we got started, right? But the team makeup and size really kind of does depend on what the user needs are for that particular opportunity, right? Like I said, kind of this is a broad spectrum of the roles that you may need in your Smart App development team. So not only a data scientist, but maybe a PM, also some engineers and also some designers, right? And one thing that I did want to kind of highlight here in the context of VMware Tanzu Labs is that when we're kind of building these smart apps in collaboration with customers, we're not doing this on our own, right? In this diagram of the team makeup, you can see here that you not only have the Tanzu Labs roles, but you have kind of what we call paired client roles matched up one-on-one with each of the Tanzu roles, right? And when we work on projects with customers, like we kind of not only are there just to solve out, let's say, improvement of search for an e-commerce app, or improving the ability to detect fraud for an internal enterprise app. But we're very much aware that after we work on a project for a couple of months, at some point we are going to disengage, right? And we're very different from your typical consulting organization where it's yeah, you're going to need us for these refreshes for the future items on the roadmap. So just call us back, bring us back in. We'd love to come back and continue to work with you, keep us utilized, keep us billable, right? Totally working against that mode of thinking. When we do a project with the Tanzu Labs team, we're not only delivering on the business goals, but enablement on the customer product teams to be successful even after we're gone and after we finish the project. This is equally important, right? And this is sort of the biggest differentiator in terms of what we offer as a consulting practice with the other options that are out there, right? We don't just drop in, develop models, deploy smart apps and leave, right? We work side by side with your teams to build capabilities and instill a process, a culture that shows not only an immediate impact, like the examples that I shared in the first section, but also something that's lasting. So that after we disengage with you, your teams are fully equipped with the skills, the methodologies, the processes that are needed to continue development on the roadmap on your own. Right? And this is kind of what we call the enablement goals of the project. Right? Now, how do we do this? Well, we do this in many different ways. And a big part of how this works specifically for the data science practice is something called pair programming. Right? And this is where a technique where two data scientists, right, work together at one workstation. And one of these data scientists is from our team, and the other data scientist is from the client teams, right? And so it's one workstation with let's say one computer, two monitors, two keyboards, two mice, two people, right? And what happens here? Well, we're all staring at the same screen, and the Tanzu Labs data scientist and the customer data scientist, we basically just take turns coding, right? So it's not, again, just because it is a consulting, project. It's not just us on the VMware side that's doing the code and driving kind of development work. We take turns with our clients. This is awesome for many reasons. Number one, it's like live QA, right? So like, oh yeah, I gotta like figure out this specific, syntax of some Python or R function that I'm using. Maybe my pair will know, or maybe I will know, if my pair is driving and writing the code. It kind of provides this kind of driver and navigator capability so that when we're writing code together as paired data scientists, one person who is driving, kind of writing the code, is really focused on the details and the implementation. And the other person, the navigator, is kind of looking at the big picture and making sure that we're on track with the stories that we're developing against, and providing also a second pair of eyes to review the code as the driver is writing that code. Right? And it's not like, I don't know, the VMware data scientist is the navigator all the time and the client side data scientist is driver, and vice versa. We switch roles. And so at any given point in time of the engagement, the VMware data scientist may be the driver in some cases, and then the client side data scientist may be the driver in other cases. So whether or not it's in the context of a consulting engagement, pairing in and of itself is just great for internal data science teams, right? Which is something that we highly encourage. Specifically in the context of a consulting engagement though, why pairing is awesome is because like literally we're coding together, and both you and I as the client and the consultant have full knowledge of this code. Even after we disengage, no issue. The client-side data science teams have full ownership of the code. They know how to fix bugs. They know how to tackle the remaining items on the backlog. They're good to go, right? And so this method of working pair programming is not only great just as a general practice, but it works also super well in the context of client consulting relationships. And so this is kind of one of the key ways, pair programming, in which we make sure that we're tracking against our enablement goals when we collaborate with customers on projects. Right? So hopefully kind of what I've described in terms of, I guess, being focused on users, adopting agile practices and processes to make sure that work is being done in the right way, and also kind of the enablement goals that we set up when we work together with customers, so that ownership of the work that we're doing is secured post-engagement. Like a lot of customers and clients still ask me like, okay, like, yeah, like Agile, UCD, user-centered design, I kind of understand it in the context of regular apps, but how does that work for like data science, the data science practice and smart apps in general, right? And I guess the best way to think about it, right, is to think about smart app development and the data scientists in that product team building the smart app as going through a continuous repeated cycle of innovation through validated iterations. And I'll tell you what I mean by that. So the first thing that we do is, let's say we have some requirement to, or a user need to, I don't know, build, let's say, a recommendation engine, right? We ask our data scientists and our client data scientists to please take a moment to build a simple model. And believe it or not, this is very hard for data scientists to do. I don't know what it is. Maybe it's the academic training that we kind of, grew up with, or like kind of what they teach you in school or what have you, or in other organizations. But like data scientists get very nervous when you ask them to like, can you share your models? Can you share progress of how your models are doing with other people? They're like, oh, no. It's not ready yet. It's got to be like academic paper publishable grade ready for me to be able to share a peek of this thing that I'm building to anyone else. It's like embarrassing if I'm not like completely sure about all the statistical principles that have been fulfilled and kind of all the checkboxes are in place before like my data science ego is tested by sharing this model with other people. And we think that that's a completely ridiculous way of working, especially in the context of building smart apps, right? You got to be comfortable as a data scientist just building something simple, like an average, a median, and sharing that with end users as a medium to get feedback, right? Remember, like products are useless without users, right? And so we as data scientists might think that we're building something really cool and interesting, but our users might not, right? And at the end of the day, if we need to make our users happy, right? We need to make embed models within smart apps that are delivering on user needs, right? And so it's all about kind of building something simple. This is kind of a played out analogy, but like if we apply lean thinking to build a product to get from point A to point B, like the first thing, a simple thing that you might build is a skateboard, right? Now, more fittingly, in the context of building, let's say, a recommendation engine again, right? Maybe rather than a skateboard, like we might start with something that's, I don't know, simply offering the most popular, best-selling product to customers at any given point of time, right? That's probably the simplest thing that we can start. So, start by offering and recommending your best sellers to customers, right? And then we kind of share this with users, right? This kind of becomes, I guess, the first earliest testable product, earliest testable app, a recommendation engine that's providing the most popular item as the next best action for the customer to consider buying, right? We share that with the end users and we get their feedback, right? I don't know, maybe we get feedback from, yeah, this is great, but you're kind of telling everyone to buy the same thing. Not all people are the same. We may need to make this a little bit more personalized in terms of my specific preferences, my specific demo, my specific needs, and lining that up with the products that you're selling and offering in your recommendation engine, right? And so another kind of incremental step there might be to, I don't know, rather than just offering up in the engine the most popular product globally, offer up the item that's sold most in that specific customer's geography, right? As a way to kind of fine tune that a little bit, a small baby step to get closer to full personalization, right? And then maybe also adding like time of day, like depending on, let's say if it's an e-commerce scenario, like if you're searching in the daytime versus if you're searching in the nighttime, if based on your geolocation also, maybe depending on where you're searching from, what devices you're searching from, maybe we tune that and we take into account different best-selling items grouped by and depending on the time of day, the geo of the customer, et cetera, right? And we repeat this process, right? Getting feedback, improving and adjusting by layering in additional data sources, trying out additional algorithms, right? From kind of skateboard to bicycle, right, to car status, right, to use that age-old analogy, right? And then we kind of get from the earliest testable product, right, kind of that, oh, give me that best-selling item globally, to what we become the earliest lovable product. Maybe it is, something, a recommendation engine, where now we're providing product suggestions to the user that have been purchased by other customers with similar tastes and preferences to you, right? And kind of one way of kind of personalizing that experience and providing more contextual, more meaningful recommendations to clients. And we're not going to get to that point for the context and the scenario that we're selling for, unless we get that user feedback, right? So with each additional cycle that we go through, with each additional iteration, we sort of meet user delight, we increase business value through the smart app. At the same time, we decrease risk, and we also mitigate misalignment with what end users are looking for versus what the product team is developing in the smart app. So hopefully that was a helpful overview of the methodologies that we adopt as key foundations to help our customers become more adept and build the foundations to building better smart apps. I'm going to spend a few minutes now on the tech, right? Now, as I mentioned in the beginning, like, yes, there's going to be different tools and tech depending on the role that you're talking about within the smart app development team. If you're speaking with the PM versus an engineer versus a UX designer versus a data scientist. In this presentation, I'm going to be focusing primarily on the tools that are needed by the data scientist, right? And when we think of an ML workload, right, there's like justifiably a lot of attention when we think about what a data scientist does on the ML models, right? Yeah, like we're building, I don't know, a way to offer better recommendations to customers. What algorithm are we going to use for the recommendation engine? Collaborative filtering is something else that you're using, right? let's talk about we're building a fraud detection model for an enterprise app, like the one that we saw earlier on in the session. Okay, are you using logistic regression, a neural net? Are you using support vector machines in your algo? What's going on under the what algo are you using to make that possible? And that's very natural. It's very natural to latch onto that, right? In terms of the algorithms that are being used and like the AI engine that's being developed in the context of developing a smart app. But the reality is that data scientists, we're doing a lot of plumbing work, right? Not just like testing out different algorithms, but then I don't know, okay, let's say we're building this recommendation engine, right? We're training data to build a better recommendation engine. Training data, right? Well, where am I going to get the data from, right? The past historical purchases and the transactional data of the customers that we're dealing with to be able to build these recommendation engines. Well, we need a way to provision that data and get that data from somewhere, right? We need like a database, some type of data store that the data scientists can easily access and query to be able to actually do this work. Secondly, developing these ML models, we need a development environment, like Jupyter notebooks running Python and R and SQL. Yeah, it's great, but then is there a server that these data scientist teams can connect to provision these environments with the right CPU, RAM, storage, GPU capabilities to be able to do this work? I don't know, right? We need to find a way for these data scientists to find a place to be able to be productive, right? And let's say they've made it past these really big hurdles, and they're ready now to deploy this, let's say, recommendation API service that, let's say, the software engineers can then ping to build out the front end app for the smart product. Well, where am I going to deploy this thing? Is it I'm not going to deploy it on my laptop, but the engineers can't access my laptop to be able to make these prediction calls, right? I need a serving environment to make this possible and accessible for the engineers to integrate with their front-end applications, right? And it's because now data scientists are scrambling to find places to do their work, you end up spending more time on setting up infrastructure and less time actually developing models, right, in support of the smart app, right? And this is pretty challenging, and what we've put together at VMware is actually a curated portfolio of products that we believe are cherry-picked to rapidly enhance data scientists' productivity, right? And the one slider here is an attempt to give you all an overview of what these components are, right? I guess at the bottom of the stack, you'll have the virtualization and orchestration there, provided by vSphere, Bitfusion, which is a technology that we offer at VMware for virtualizing GPU system resources, and then also Tanzu Kubernetes to provide the orchestration there. Right? Now, Kubernetes, it's great. Provides a lot of value for a lot of engineers and platform operators. You show a Kubernetes environment to a data scientist, in many cases, they're going to get scared off, right? Data scientists most typically speak Python or an SQL. They're not cloud native, platform architects, right? The good news here is that there are interfaces for data scientists to be able to harness the benefits of these cloud native platforms. I've listed a few here, open source option with Kubeflow, right, which runs directly on top of Tanzu Kubernetes, and then Dcube, which packages together not only Kubeflow, but also MLflow, and then Domino Data Labs, which also package together these MLOps tools that run directly on Tanzu Kubernetes. Right? And so what you see here in the purple box kind of becomes the IDE, kind of the development environment for the data scientists. You're going to be able to get your Jupyter notebook servers. You're going to be able to deploy your models as APIs by using the components in the purple box. Right? And of course, I talked about the need to be able to query data. And sometimes also Python, R is good, right? Especially when you're dealing with smaller size data. But what if you're dealing with terabyte and possibly even petabyte scale data, like the one that we encountered with the 10 million records of data that we need to process for the fraud detection engine that I introduced earlier, right? Well, you're going to rapidly run out of memory in Python and R very soon when you're trying to do that type of work on 10 billion records of data. The good news here is that through components in our Tanzu Data Services offering, we have a product called Greenplum, which is a massively parallel processing compute engine that's able to operate very easily on petabyte scale data. And so the data scientists now able to make SQL calls to process billions of records and get results back in a matter of seconds so that they're not waiting for results to come back. In some cases, if you're doing this in Python or R, they're never going to come back, right? Because the data is the memory is going to run out in those runtimes, and you'll be just kind of stuck to do sampling, right, of the data. And then, of course, up on top, through again that kind of Tanzu Labs experience through that program with a consulting organization, we're not only able to provide you with enablement on the methodologies and the processes and the way of working, the culture, right, that is described in the methodology section of this talk, but also training and enablement on these key components of the tech stack, so that after working together with us, your data scientists are going to be much more productive than they were before they started working with us from a tech perspective as well. So I know we just have about 2 more minutes before 5 minutes, for the Q&A, but I did want to kind of close off, by sort of, giving you some ways in which to get started, right? If you found that some of the things that I've talked about today in the session are interesting and you want to find out more, please do consider partnering with us, right? We'd love to get a conversation started. Let's do some whiteboarding sessions, right? To learn more about kind of your users, the needs and the challenges that they're facing. We'll do some sessions to establish a shared understanding of the goals that would be meaningful to build against, and then also the users that we're aiming to target with these smart applications, right? Secondly, after we do a little bit of whiteboarding initially, what we recommend is something called a discovery workshop, right? It's a facilitated session that we offer running from a couple of hours to a full day, depending on the opportunity, right? And we'll kind of dig deeper into your systems. We'll identify kind of where to start, how to measure success, do some planning in terms of what we think the level of efforts look like to build out, let's say, an MVP for the smart app, and outline not only the business goals that we want to achieve, but also the product goals, and then also the enablement goals that the team would be targeting against throughout the entire project, right? And kind of what you get back as clients at the end of this discovery workshop is a proposal, right? And so we get just enough information in this discovery workshop to come back to you with a proposal document that outlines the scope of work that we'd be working together on. Right? And then last but not least, if everything looks good and we're ready to get started, let's do this thing, right? We do a project together. Let's build an MVP. We'll do some pair programming, and we'll build out some quick wins in terms of developing smart apps for your organization and for your end users, right? And we're going to be doing that by enabling you on the experiences that are needed and the expertise needed to be able to build the foundations for continued success in building smart apps. Also the right methodologies to ensure continuous innovation, and then also enablement on the right technologies so that your data scientists are most productive, spending more time coding, less time figuring out infrastructure. All right, so I know we've just got 5 minutes left for the Q&A, but hopefully you found that helpful. Please do reach out to me. You'll find my email contact here if you have any questions or want to get in touch after today's session. I know you all are super busy and we have a big group here joining today, so thank you all for the time. And please do reach out if you have any questions. Thank you again. Urim, I'll turn it over to you for Q&A.
Yeah, thank you sharing the session. And we have one question. So you can see the Q&A box if you pick up the Q&A.
Oh, yeah. Oh, cool. Yeah, Binsar asked a question. Does that mean, I think this was regarding, does that mean you save the geolocation of every packet to your database? I'm trying to remember maybe what use case. I'm guessing it was one of the case studies for the smart apps that we had developed. Oh yeah, this probably was for the delivery without postal codes. Yes, you're exactly right, Binsar. In addition to the kind of what we call the basic data that we had about the parcel, including the sender's name, the recipient's name, the sender's address, the recipient's address, again, without a postal code, historical geolocations, yep, of the couriers as they were delivering the parcel to the recipient. And we made use of that as a part of the engine that we embedded into the Smart app to provide decision support on deliveries. Yep, that's a great question.
Thank you. Thank you, everyone. Thank you for joining us. And we look forward to seeing you at the next webinar. Bye, everyone.
Sure.
Thank you. Thank you.
Thank you all. Thank you. Bye-bye.
Bye.